Hi everyone, this is EasyPeps and welcome to another video. In this tutorial I'm not going to create any particular effect. This video is a list of 10 useful tips for someone who just started to learn Houdini, or maybe not. I actually learned a few of those pretty late in my Houdini journey, so I hope you will find those tips useful and convenient for your workflow, and let's get started. So, tip number 1 is how to use Houdini global variables. Now, if you work with Houdini even a little bit, you've for sure encountered those dollar words written somewhere. And these are Houdini global variables, which mean inside these variables is stored some value. It can be a number, it can be a path, it can be a name. And to look for this list, you just need to search for variables inside your Houdini help and open this page hscript global variables. It will open this page, and at the bottom of it you can see the list of Houdini global variables. There are a bunch of those variables and I honestly never used a lot of them. I believe the most used one are the one that allows you to access your frame information. So $FF gets you the current frame number, fstart, fend tells you the start and the end of your timeline. Also heap and job, all the variables that let you define the path where you're going to save and load your assets are super important, and also $OS because it takes the name of your current node. But let's see in practice. So let's say I have a geometry and I want to save this beautiful box on a geometry file, so I use a file cache node. And right away, I don't like this new constructed format SideFX had implemented in Houdini, so I switched to explicit. And right away, you can see that Houdini is already using some variables to save this geometry. It's using the heap variable, which is the folder containing the scene file, the heap name, which is the scene name, the OS variable, which is the current node name, and the $F, which is the current frame number. Right now I don't have a project or a scene file, so let's create a new project and choose a location for it. Let's call it 10 tips. So now we can save the scene, and even when saving you can use Houdini variables. You can see here the job variable, which if we open the list from before is the project directory itself. So we actually have now a $job variable set. So we can use this path to save the scene file. So let's call it 10 tips. And by saving the scene file, we define the heap variable because it's the directory containing the current scene file. So now we have defined the heap variable and also the heap name because it will take the scene name. As for the OS variable, it will take the name of the current node, so it will be called filecache1. Let's change it to box out. And the $F will take the current frame number. Now, if you have a parameter that is using variables, if you middle click on it, you can see the actual output. So you can see everything is correct because we set up our variables correctly. And you can actually inspect all these general variables if you go on the edit and aliases and variables. On the second tab you will see all the general variables listed. You have job, heap, pi, and all this stuff. And the cool thing is that you can actually create new variables. Meaning, let's say I have a simulation I want to save, and I don't save my simulation cache on the system hard drive where I have my current scene file. I save it on another drive. So all you need to do is go on the path you want to save the file, or rather you want to define the variables. Just copy the path and let's create this new variable. We will call it sim and we will paste the path here. Just keep in mind you have to reverse the slash. So the variable is being created, and if we take another file cache, we can define our path to the new variable. So let's switch to explicit, delete all this stuff, and let's say I want to save this file in my new sim variable using the node name as a subfolder, so $OS, and right now is taking file cache 1, so let's rename to nice sim. And we want to add the frame number and the extension. So let's middle click on it, and the path is correctly set to the new variable. And of course you can create new variables pointing to name or numbers. It doesn't have to be a path. And of course you don't have to use variable at all if you don't want it, but I believe that once you understand how they work, and they are pretty simple, they are pretty convenient to speed up your workflow. Tip number 2 will be super quick, is how to reset your viewport. It happens sometimes that Houdini viewport gets stuck. I can't exactly replicate it right now, but for explanation's sake, let's say I create a sphere and I have the blue flag on the sphere, so I should see it, but I keep seeing the box. It happens sometimes. Sometimes you can fix it by switching back and forth inside the geometry or switching geometry at all. Back in the days, the safest way to fix this issue was to close a scene view and open a new one. So you close the scene view, and with the plus button you create a new one between the viewers tab, and this will fix this issue. Recently SideFX added a convenient button for us. If you go to help, you can reset the viewport, which does basically that, meaning closing a scene view and open a new one. So it's convenient to have a button that will save us one click. Tip number 3 is how to use visualizers. You may already notice that almost everything you do in Houdini is based on attributes. Attributes are the way Houdini will store, manipulate, and carry your geometry data over your workflow chain. And visualizers are basically the way Houdini will show these attributes inside the viewport. So let's see how they work. Let's delete this stuff and drop down a simple sphere. And by default, you already have some visualizer ready to use, because these buttons, like the display point number or display point normal, are basically built-in visualizer ready to use for you. You can turn on the point number, and you can even see the point normal. Even if you didn't create point normal, by default Houdini will assign some normal to the vertices, and this is the reason you are seeing them green. If we create a regular normal node and we assign the normal to the points, you can see they turn blue, and these are the regular point normal display. So let's create some other attributes with a point wrangle, and let's see. We want to create a new vector attribute. We will call it up, and it's pointing up in the y-axis. And let's just lower the frequency of the sphere so we can see it better. To create the visualizer, you have two ways. Either you can click, hover on the node and click on the eye icon, and then you can click on an attribute to create the relative visualizer. Like, we can click on the up attribute, and this will create the visualizer for it. By default, you may not see it because you may have this button turned off, which is the global switch for the visualizer. So just left click to turn on and off this button. If you right click on it, it will open the visualizer list. You have the common one, which are shared between different scenes. The scene one are relative only to the scene where you create the visualizer. And this one on the right are to be created only on a particular node or a geometry, I guess. I never used those one, and neither the common one. I always use the scene visualizers. So you can see in the list the up visualizer has been created. Let's see the other way to create a visualizer. So we can hide the point normal, we can also hide the up visualizer. Go back into the point wrangle. Let's write something like, if the point position on the y-axis is less than 0, we want to create an attribute, a string attribute called name, and we will call it, I don't know, negative. else we can create the same attribute and call it positive. So basically we created an attribute, a string attribute, which can be negative or positive based on the point position on the y-axis. So the other way you can create a visualizer is by going to the visualizer list and click on the plus button. This one is a text attribute, so it's a marker one. And to link the visualizer to the attribute, we need to set the name correctly here. So the attribute name was name, and you can see that it's already working. Now the name and the label you see here are relative to the visualizer, not the attribute itself. So I strongly suggest you rename the label because it's the one you will see in the list. So if you have a bunch of visualizer, it's convenient to quickly recognize the one you want to turn on and off. And when you create a visualizer, you have a bunch of different types and style, which will change according to the type one. For example, the body text one and the vector one are under the marker type. If you need to create a color attribute, you can change the type and the style will also change. So just to give you a couple more examples, let's say I have a curve. I have this curve and I want to measure this curve and I want the measure to be displayed as a visualizer. So let me resample the curve to have a polygon geometry and node NURBS. And let's add a measure node to measure the length. So change the type to perimeter length. Over the node, click on the eye icon and click on the attribute to create the visualizer. By default, most of the visualizer are created as a color type, so you may think it's not working, but it is. We just need to change type. So let's right click on the visualizer list, click on the pencil icon to edit the visualizer and change the type to marker. So we have our visualizer with the measure correctly working. And as a final example, just to show you a different type of visualizer, let's create a sphere and scatter like 100 points on it, so we can fracture with a Voronoi node, which needs the geometry to fracture on the first input and the scatter point on the second one. So if you enable the primitive piece checkbox, it will create an attribute based on the piece. And if we create the visualizer for it, it can be a color one, so it's already correct. And you can see a color visualizer in action. So visualizer are super useful. I strongly suggest to use it all the time, also to debug problems on your scene, but even to just understand how an attribute's behavior is working in Houdini. Tip number 4 is about curves. In Houdini, 9 times out of 10, when you're working with curves, you're going to need the same attributes every time, which are the CurveU and some properly aligned vector, typically the normals. So let me explain. We're going to create another curve and choose NURBS, and let's draw a simple curve. Let's try to make it three-dimensional. And we're going to need a resample node, and let's say we want to copy a bunch of boxes on these curves. So let's take a copy to points. We connect a box on the first input and the resample node on the second input. Let's lower the uniform scale and maybe the resample length, so we don't need as many points. So this is the typical use of a curve in Houdini, basically, when you want to copy some geometry on it. And you can see that the boxes are uniform, both in size and orientation. And let's say we want to make the sides to increase from the start to the end of the curve, and we want the boxes to be aligned to it. For the orientation, basically, let me turn on the point display and the point normal display. All we need to properly orient the boxes is basically a point normal vector which is aligned along the curve. And we can actually use a polyframe node to get that. So take a polyframe node and connect it after the resample one. By default, the polyframe will generate both a normal and a tangent attribute. The normal is basically a smoothed version of the previously incoming normal, and we don't have any normals, so we can turn off this one. And the tangent is basically a vector created following the edge where the point lies. So if we rename this one to n, it will be wrote as a normal, and we can see it with this visualizer. Now, as you can see, it's not perfectly following the edge because it's set to 2 edge. So it's doing, I guess, a sum of two different point values. So if we switch to first edge, we have a perfectly aligned normal attribute on the curves. And if we switch to the copy point, we can see that the boxes are now aligned. Although there can be minor issue, like you can see here, because to properly align your copies, you're going to need also an up vector attribute. And we can create it just with a point wrangle. And this has to be a vector attribute, so b at up is equal to a vector which is pointing up in the y-axis. So you can switch this one on and off, and you can see that the up vector actually fixes this issue. To control the size of the copies, we are going to need an attribute called the CurveU, which is a float attribute that goes from 0 to 1 from the start to the end of the curve. And we can get it by the resample node. You can enable this checkbox where it says CurveU attribute, and this will automatically generate the attribute we need. If we go on the geometry spreadsheet, you can see it here. It's going from 0 to 1. And like I showed you before, we can always create a visualizer for it, which by default is being created as a color one. So let's switch it to marker and text. And you can clearly see the attribute is working. Now you can use this CurveU attribute in many ways to control the size of the copies. I usually do it in a point wrangle with a ramp parameter. So let's create a float variable and call it pscale. And we create a ramp parameter, we will call it size, and we will use the CurveU attribute to drive it. And of course we have to write this variable into a float parameter, a float attribute. So f at pscale is equal to pscale. Click on this button to create the ramp, and by going into the copy points, you can see that everything is working correct. And this is working just right off the box because the copy to points is set to use the pscale attribute if you have some pscale attribute from the curve to set the scale of the copies, as is set to use the normal value to orient the copies. You can see that turning off the transform using target point and orientation, we turn off both the scale and the orientation we did. And I believe both CurveU and normal along with the up vector are super important whenever you're working with curves in Houdini. Tip number 5 is for when you have a situation like this, that you have a bunch of scattered geometry and you want to get a single point at the center of each closed geometry. And this may be not so useful if you just work with Houdini, because whenever you're working with scattered geometry or even simulated pieces, there's almost always a way in Houdini to get or to keep the points at the origin of the geometry. But let's say if you get this kind of geometry from another 3D package, you may not have directly access to the points. So for the sake of this explanation, let's say I don't have this point, which are the one that I'm going to get at the end, and I just have this as a regular geometry. I can think of two ways to generate those points, and both ways are intended to work with packed geometry, which is basically the way Houdini create instance of geometry. If you have a copy to points, you can create packet geo just by enabling this packet instance, and Houdini will create a packet geo for each point you scatter the geometry. So we have 50 polygon for 50 box and 50 point. But we say that we received this geometry from another package, so let's say we can't use it and we need to pack this geometry in another way. To do that, we use a node called the assemble. So plug the copy to point into the assemble, and you use this node to create groups or attributes or packet geo based on the connection this node will find on your geometry. So if you enable this create packet primitive, and you can disable the second one, it's a more advanced thing, we don't need it now. And if you middle click, you see you have the same result as the packet instance of the copy to points. We have 50 polygon, one for each box. The first way to generate those points is with an add node, which you usually use to generate points or polygon, but if you connect it to another node, this option will become available: delete geometry but keep the points. Let's say we don't have packet geo. If we enable this option, it will be just that, so it has deleted the polygons but is keeping the points. And when you are working with packet geo, every single packet geometry is represented by a single point at the center of it. So if you are packet geometry, we have just the point at the center of each copy, and that's exactly what we want. The other way we can generate those points is with some Vex code. So let's take a point wrangle, and all we need is a single line of Vex. We're going to use this function, remove prim, which removes the primitive from the geometry, and we need a geohandle, a primitive number, and 0 or 1 for the third input. It depends if you want to delete or not the points. We want to keep the points, so in this case it will be 0. So it's remove prim from the first geometry on the current primitive number, and we want to keep the points, so 0. And there you go. If you middle click here and on the add node, we have the same result. Tip number 6 is another super quick one. It's just to say that you can actually save your own Vex code. So things like this up vector, you will use it a lot, so it's convenient to have a preset and don't write it every time. So you just need to have your code in a point wrangle, click on the gear icon and say save preset. You can name it whatever you like. Let's call it up vector and let's save the preset. And to apply, you just need to go on the gear and choose your own preset. You can see that I have other ones. You can just choose the one you want, in this case up vector, and there you have it. Tip number 7 is about viewport. In Houdini, you can pretty much customize your entire workspace, whatever you want. This is the default build one. I usually don't use this one when I work. I have the viewport and the geometry spread shift on the left monitor and all the network view and parameter on the right monitor. This of course is totally up to you, but it's convenient to know that you can actually pin the workspace window. Which means if I have a geometry, let's say we have a box, we have some scatter point just to have a couple of nodes, and by default the parameter on the upper window are the one of the last selected node. If you right click on this little pin icon, you can see that it's a last selected node, so whatever node we are selecting, we get those parameters in the upper window. If you want to have some parameters always visible, you just need to click on the pin icon or right click and say no link. And now, whatever node we are selecting, we always display the pinned one. Now, let's say I have another geometry with a sphere and a normal node. And I want two separate network views relative to each geometry. So what we can do right now is to click on this little arrow and say split pane left right. And do the same for the network view. Now we dive into one geometry, right click on the pin icon and choose a number, and choose the same number for the parameter window. On the right side, we do it with another number on the other geometry. So basically we have linked the network view and the parameter of different geometry. So basically the parameter displayed on the right and left side are relative to the last node selected on the relative network view. And for the viewport, let me just say hide other object. By default, we are seeing the last selected node because we have the same setting here, and we can link it to a specific number or say last selected node, or even no link at all if you want. It's up to you, but it's a super useful thing to know if you have to, I don't know, maybe link multiple parameters. So having both the source and the destination visible is super useful, so you don't have to do back and forth inside different geometries. Tip number 8 is about chops and MotionFX preset. You may already know that in Houdini we have different contexts depending on what you need to do. Right now we are in SOP context, which stands for surface operator, and we have many other contexts like the DOP context, which is used for dynamic stuff. We have the LOP context, is the new Solaris one, and we have also the chop context, which stands for channel operator. I don't have a perfect definition for the chop context, but basically it's the place where you do some animation, where you do rigging or constraint, and even if you want to do some audio processing. Let's say you have an audio file that you want to use to drive your animation, you do it in chops. Now, I'm not an expert on chops or animation stuff, so I won't go too deep into this, but the basic principle is that you have some channel you want to animate, and a channel is basically a single parameter. So let's say we want to animate the translate Y of the sphere. All we need to do is to create some chop network, which is this one, and the inside is what you're seeing on the right network view. So you take the channel you want to animate and you add to it some chop operator. In this case, I took the translate Y and I added a wave operator to it. And in this way, I created this kind of animation on the sphere. Now, you can create all this stuff starting from scratch, by all means, if you want. You can create a chop network, dive inside, and create all this node for your animation. But the good thing about MotionFX is that you have some presets available. So let's see how to use it. Let's create another geometry, take a sphere, and we want to do the same thing. We want to add a wave animation on the translate Y. So we take a transform node, and just let me make some room here, and it will be convenient to split this one from top to bottom. I will explain you why in a second. And on the channel we want to apply the chop stuff on. We right click, and while it says MotionFX, we have all the MotionFX preset. So let's choose the wave one. It will open the MotionFX view. So I will close it and reopen it over here so it's more clear. So basically Houdini has created a chop network and applied a wave operator to the selected channel. If we dive inside the chop network, we have the correct name here, which is the translate Y from the translate one node, which is the transform node we created, and we are applying to it a wave operator. Within the wave node, you have all the parameters to control the animation for the period, the phase, the offset, and the amplitude. And what you're seeing down here is the MotionFX view. Basically, you are seeing these operators as an animation curve. So if we put it on play, you can see that it's working. And if we change the parameter, both the animation and the MotionFX view are updating correctly. Now let's try another preset. So let's take another transform node. And this time on the uniform scale, we right click MotionFX and we add a noise operator. Close this window because we have the MotionFX open right here. And as you can see, Houdini has not created another chop network. You don't need to create a chop network for every operation you need to do. You can use the same one. Because unlike the surface operator, it doesn't matter where the blue flag is. The actual flag that will export your operation is this orange one. because this orange flag will export this operation to the selected channel. If you go on the transform node, you can see that you have an orange flag here. This means that this channel is controlled with a chop network. So you can actually merge those two transform nodes and you have both of the animation working. And that's basically it. I honestly don't use chops very often, but this MotionFX preset stuff is pretty convenient if you want to do some quick animation. And for this tip I chose the wave and the noise operator on purpose because they actually create animation. If you want to experiment the other one, keep in mind that, I don't know, the smooth, the shift, the lag and other ones are intended to modify an previously existent animation. So if you want to see how they work, you need to do some animation prior to the chop network operation itself. Tip number 9 is always experiment. In Houdini there's rarely a single way to do something, and just because you found the solution to achieve what you need, it doesn't mean you can find a better one. Maybe you find a more flexible solution or a lighter solution in terms of computational cost. Like here, where we deleted the primitive to keep the points. Both the add nodes and the point variable do the same thing, but if you middle click, you can actually see the memory this chain is taking so far, and also the time this node is taking to process. And as you can see, the point variable, being only a single line of code, is taking just a 0.03 millisecond. The add node, being a more complex node designed to give you more option to work, is taking 0.46 millisecond, which right now is nothing, but when you will start to have more complex setup, the optimization of your workflow will become something that matters. And generally speaking, it's always useful to know different ways to achieve the same result. And latest tip for this video is tip number 10. You need to start to think in a procedural way. Houdini is a procedural software and it's born as a procedural software. It's not something side effects added later on, which means that almost anything you will need to do in Houdini can be done in a totally procedural way. So to explain what I mean, let me create another geometry. And let's say we have a box and we just want to bevel the edges. So we drop down a poly bevel node, we select our edges and choose the bevel size. Bam! Hashtag procedural modeling. It's not like this. Houdini is designed to work in a non-destructive way. What we did right now is a destructive workflow because the selection itself is based on point number, which means if we change the division of the box, the bevel node will stop working correctly. So you need to, at least at the beginning of your Houdini journey, you need to constantly question to yourself, will this work if I change something prior in my chain? And if not, how can I make this workflow procedural? In this case, it's super simple. You just need a group node that you can put it on edge mode, disable the base group, and enable this include by edge. So we can actually decide the minimum and maximum edge corner that will be assigned to the group. So we call it bevel. And in the bevel node, we delete the point-based selection and write the name of our group. Now it's really procedural because you can change the division size, you can change the size, you can change everything of this box, and the poly bevel node will always work correctly. And in my opinion, this is a super important concept because, especially if you're coming from another software, you may already notice that Houdini has a very steep learning curve, and also that procedural modeling itself is slower to create compared to traditional modeling. And that's totally normal because if you want to be able to change things in your workflow, you need to consider a lot of variables. So the creation of the setup itself is slower. But the real advantage you get it's on the long run. When you will start to have your own procedure, your own sub-networks, and those are done in a correct way, you can basically adapt them to every setup you need in Houdini. And even if you don't do that, you can always go in an old scene. I do it all the time, grab things, grab entire setups, and if they are done in a non-destructive way, they will require minimal change to work on your current project, even if you consider just these two nodes. It can be a stupid example, but basically with two nodes, we created a setup to bevel sharp edge, and theoretically it will work with anything as long as your need is to bevel sharp edge. So let's say we can replace the box with a tube, and it works. Another important thing, in my opinion, is you don't need to be afraid to branch out, which means if you do something like this, let's say, let's keep the division to 2, and we select top and bottom face, delete it, we copy the blast, revert it to non-selected, so we have on the left side the sides and on the right side top and bottom, and we merge back in. Now pretend I did some complex operation on the left or the right side. It may look that something like this, it could be wrong, but it's totally fine to split your workflow according to your need. As long as you merge back in, you remember that we need to fuse also the points. So branching out to do separate procedure or even only to testing things, you can branch out, so you will not do this work and you can test whatever you want on a separate branch. It's super useful in Houdini. Let's just say that if your workflow looks something like this, there's something wrong. You're not using Houdini at its full potential. A classic Houdini scene looks more like this, where you have branches, you have subnetwork, you have expression, and you shouldn't be scared about that because this is how Houdini works. Even if it may look messy, this is not actual mess. This is your entire workflow displayed as once in your network view as nodes, and you should take advantage of that. Because once you understand how Houdini reasons, you will start to notice the real advantage of procedural modeling. And I believe that's it for this video. I hope you enjoyed my content. I hope those tips will be useful to your workflow, and I hope to see you in the next one.